Sound is half the experience. The famous director of the Star Wars, George Lucas, once said, "We can't imagine going to cinema watching a film without sound," right? But sometimes we don't realize how important sound is in our daily life. We're always surrounded by sounds, and sound plays such an important role in many things in our life. So for example, what we see, the field of view is so limited. It's just about 135 degrees. We are not fish. Fish has 360-degree field of view, but they have very limited hearing ability, obviously. But humans can hear sounds in three-dimensional way. Okay, so this is what we have in everyday life, but sometimes we don't recognize what we're hearing because we don't pay attention to sounds we hear. But when you go to a concert hall and listening to an orchestra performing in a nice concert hall, then the orchestra is in front of you. What you hear is mainly the musicians playing instruments, but that's not the only thing that you're hearing in such a space. You're hearing reflections bouncing off the walls and ceilings and all the lovely reverberation, the ambience basically surround you. So we're always kind of surrounded by the sound field. Even in this space, when I speak to you, you see me and you may think the sound is only coming from me, but you're hearing all the reflections and reverberation from the walls. So effectively, we are surrounded by this 3D sound field right now. So when we record a sound and reproduce over an audio system, stereo is what we are so familiar with, two speakers, left and right. But this is very limited because we can only reproduce the sound from left to right. This is one-dimensional. We only have width dimension. It's slightly better with surround sound, 5.1. So when we watch a movie in a home cinema, if you have surround sound system, you have additional center speaker that is designed for dialogue. So you will see only the actor's dialogue comes from the center speaker. That kind of gives you an anchor point. So wherever you sit, left and right, wherever you sit, you only hear the sound of the actor from the center position. But you also have the surround speakers that is designed to envelop you in the sound field, so you can hear the car from behind. And also, if you have virtual height surround sound system, then you can hear airplane everywhere in the room. So that is better than stereo, but it's not fully 3D yet. So before we come to the 3D part, I'll just briefly explain how we localize sound. Have you ever wondered how you can localize sound from there and behind you or above you? I mean, again, we are so familiar with what we're hearing, and that's a natural experience. But if you start wondering about how it works, there's a certain principles. So when there's a sound source on your right-hand side, this sound will arrive at your right ear first. And we always have this time delay between the sounds arriving at one ear and the other ear, because the ears are spaced apart by around 17 centimeters on average. So this time difference is what we call interaural time difference. And it could be just up to about 0.7 millisecond maximum when the sound is right next to you. Then this maximum delay that you can have between the two ears is only 0.7 millisecond. It's a fraction of time. You can't even count this. But this is a huge number for the brain. The brain processes all these little differences between the ear signals and try to make sense what's going on in the outside world, where the sound comes from. But this is not the only cue. So we also have level difference cue. So the same sound source radiating sound from the right-hand side, then the wave will propagate and pass through your head. So your head now acts as a physical barrier. There's an error with my PowerPoint, but no worries. Coming back on. Yeah, so when the wave propagates, your head acts as a physical barrier. So the sound arriving at your right ear will be full level, but the other side, the left ear, will receive the sound at a reduced level because the head basically blocks the sound, diffracts the sound. This is what we call head shadowing effect, and that gives you what we call interaural level difference. So these two cues, time and level differences, are important for us to localize sounds in the horizontal plane, so at our ear height. So whether it's coming from left or right, we use these two cues. But when it comes to 3D audio, what do we mean by 3D audio? In real life, we have everything coming from all directions, sound coming from the ceilings, the reflections and everything. But surround sound is limited in terms of reproducing all of these cues. So we add additional speakers and try to create this height dimension in sound reproduction. And now we have width, depth, and height, all three dimensions. That's what we call 3D audio. How do we localize sound in three-dimensional way? This is a modeled external ear, a pinna. This guy has. I'll talk about this guy a little bit later. But this external ear plays such an important role for us to localize sounds coming from above us or below us, behind us, and in front of us. Without the external ear, we'll be completely limited in terms of localizing sounds in three-dimensional ways. So this is just a picture that shows that the sound coming from different directions. So let's say we have sound coming from above us, front of us, or below us. They all produce slightly different, or sometimes very different, spectral patterns, different frequency responses. So it's effectively distortion caused by the external ear because the pinna looks so complicated. When the sound arrives at your ear, high frequencies get reflected and diffracted inside the ear. So that causes very unique patterns of frequency response spectrum changes depending on the sound positions. So without the external ear, imagine that we only have two microphones at the head. So we only have two holes without the actual pinna. Then what would happen is what we call cone of confusion. We will get completely confused about the sound coming from the front and back or up and down, because if you think about this cone, along the circle, if you have sound A and sound B, they will cause the same amount of interaural level and time differences. So the brain has no way to resolve where the sound comes from. Same with the sound, so C and D. They produce same amount of level and time differences. So it's only when we have the external ear, then the brain can interpret where the sound comes from in 3 dimensions. But as you see in this picture, there are a lot of different shapes of ears. Everyone has different shape of external ear. If you compare between your friends, and you will be amazed how different our ears look. This is why hearing is very individual. Everyone hears in different ways. And as we grow up, we get accustomed to what we hear, and then the brain learns the pattern and then learns how to make sense of the sound that we hear. So we'll come back to this individual acoustic fingerprints. It's almost like everybody has got different fingerprints. No one has identical fingerprints. It will always be different, right? Our hearing is also the same. The ears look very different. So some people hear it from one position, but then we still localize sounds accurately whatever ear shapes we have, because it's not just the hearing, but we also see things. And then we also, as I said, as we grow up, we learn how to localize sounds. But it's a very individual experience. So now, when it comes to immersive audio, we hear this term immersive a lot these days. Immersive 3D audio, binaural audio, spatial audio, there are many different terms that are related. But what does immersive mean? It's kind of analog. If you look into a dictionary, the dictionary definition of immersion is the act of putting someone or something into a liquid. So basically submerge a person in the water like this, in a swimming pool. So it's completely immersive. So it's like that. In sound system as well, we have this kind of multi-channel speaker reproduction system that can submerge you in the sound field, in a 3D sound field. So it's completely enveloping experience. This is a sound studio we have at the university. So it has 24 speakers. The experience is mind-blowing. If you listen to a nice recording, recorded using multi-microphones and multiple speakers, it's amazing. It's a great experience. It can produce an immersive aural experience. And this is already happening in the real world. I don't know if you have been to any cinema that has Dolby Atmos system, but this is the new standard for Hollywood blockbuster films. All of these major films are produced in Dolby Atmos. And if you go to a cinema with Dolby Atmos systems, you will notice that there are a lot of speakers mounted on the ceiling. Usually you see only speakers on the walls, but now you have an array of speakers on the ceiling. What do? They reproduce sounds of like airplane or helicopter or some kind of thunder sound or birds. And this system can reproduce this real world sound in a more realistic way. And obviously the sound needs to be produced, mixed using the similar system. So this picture from Skywalker Sound in the US, they have this Dolby Atmos mixing system. So they produce film sound in three-dimensional way. And also we need to capture sound in three-dimensional way. So when we record an orchestra or string quartet in a concert hall, we need to use an array of microphones. And this is where my research is, how we perceive and capture and reproduce 3D audio. And what do we think about the sound that we hear? And what are the factors that affect certain characteristics of sound? And how do we control that? How do we manipulate that? How do we deliver an immersive experience? Ultimately, that's the goal of our research. So our research has been used by many industry engineers, sound engineers, and recording studios, such as Abbey Road Studios in London. It's a picture of a 3D recording session in the studio. They've been using a microphone array technique that we developed at this university. It's been used for a few sessions at the Abbey Road studio. But we can also capture sound for outside environments. So we take this kind of microphone array to a field or anywhere in the city, and then you can capture sound coming from all directions. So for example, in this case, if you place the microphone array just below the tree, then we can capture birds singing above us, and then we can faithfully reproduce the impression of birds above us in sound reproduction. This is what's inside the windshield. There's a cage. The cage is for protecting microphones from wind. And this is an example of 3D microphone technique. And the sound is also captured in 3D for football matches or any sport events, like a FIFA World Cup, Euros, French Tennis Open, all these big events, even BBC proms, these concerts are all now captured in 3D using a microphone array looking like this. This is also a microphone array commercial product that has been developed based on our research. And now, how do we bring this experience to a home environment? Because, obviously, having lots of speakers can be difficult. It may not be practical. But if you have invested all these, speakers mounted on the ceiling, couple of speakers surrounding you horizontally, you can have fairly good experience. Even if you don't go to Dolby Atmos cinema, you can experience immersive audio and films in a home environment. But sometimes it's difficult to mount speakers on the ceiling for practical reasons. Then some speakers nowadays also come with the up-firing speaker driver. So it radiates sound towards the ceiling, and then it causes the reflections bouncing off the ceiling, and then that reflection becomes a virtual height sound source. So instead of playing real sound from actual speaker, you just make use of the reflection for virtual height experience like this. But also these days, sound bars are becoming more and more popular. And some sound bars, more advanced sound bars, are able to radiate sounds to all directions, not just towards you, but just radiate sounds to the side walls. So now you have side reflections arriving from the lateral positions. That becomes your virtual side speakers. And also it radiates sounds towards the back wall, and the sound bouncing off the back wall becomes your virtual rear speakers, and so on. So there are ways that we can experience 3D audio without having a very expensive system. But probably the most practical system would be 3D audio over headphones. And this is what we call binaural audio. Binaural basically means 2 ears, binaural audio, but that's a technology developed for delivering 3D audio over headphones. So how do we capture sound for 3D audio over headphones? Most straightforward way would be to mount little microphones inside your ear canal, like this picture shows. Or this microphone, called dummy head microphone. This is Neumann KU100, which is a very popular model that's being used for music recording and so on. You can actually have a look later on after we finish. But there are microphones inserted in the ear canal, and that captures sound as if, in a very realistic way, just as how we capture sound with a real human head and ears. And the experience can be really realistic, and I'll play a demo after the talk. But there is also a way to process any sound binaurally. So we can synthesize binaural audio using some signal processing techniques. So let's say we have a 9.1 3D audio loudspeaker system. And now we place a real human or a dummy head microphone at the sweet spot. And then we capture something called impulse response. This is an impulse response, right? So there's an impulse, and then you have all the following reflections and reverb. So we capture the information from each of the speakers in the system, and we have these frequency responses for each of the speakers. So using this individual directional information, we go through a process called convolution. We multiply each of these data with a dry music signal. So if you have anything recorded using one microphone and you convolve it with all of these impulse responses, then eventually you can create the impression of listening to these speakers virtually over headphone. The experience can be, at best, almost indistinguishable between the real speakers and headphone experience. You don't know which one is real. It's very realistic. So this technology is being used widely now in many services. Like if you have Apple spatial audio, Apple devices come with an ear pod with the spatial audio, so you can actually hear sound outside the head. Even if you're wearing headphones and listen to sound, it's not going to be internally localized, but externally localized. And you can also enjoy the head tracking functions. And this kind of technology is already widely deployed, and it's becoming more common these days. So you can actually experience this from many music streaming services and also film streaming services as well. So now time to listen. So let's put on headphones, and I will introduce some examples of dummy head recording. So the sound recorded using this dummy head microphone. So I will first play something for sound check. So this is a chance for you to adjust the volume. If it is too loud, lower it. So I'm going to be playing something that says where the sound comes from. Left, right, center, real left, real right, side left, side right. And see where you hear these sounds from.
Front left, front right, front center, back left, back right, side left, side right, top front left, top front right, top back left, top back right.
Did it work? It sounds like left, right, yeah? The sound is not inside your head anymore, right? You hear it from behind, side, and top. And so this is basically a simulation of actual loudspeaker array. So if you had Atmos, Dolby Atmos 7.1.4 system, this is what you would be hearing in real life. But you can actually have a very similar experience over headphones as well. Great. So that's what the music tech is about, right? So now I'm going to play a real recording made using this microphone in this space. So you'll be hearing Mark and I having some conversation. So you'll start, well, hearing something from somewhere around your right-hand side. You might hear some door sound and footstep sound. And eventually you'll hear some conversation and see how realistic it is compared to normal stereo headphone listening. Okay, here we go.
Hey, how you doing? Yeah, you all right? Yeah. What do you want to do today then? We could do all sorts of things. Beautiful day outside. Sun is shining, not a cloud in the sky. So what do you want to do? Maybe we could go to the nearest cities. Maybe we could go to Manchester or Leeds, both great days out. Or if we're feeling adventurous, let's go down to London.
That's a great idea.
You think? Maybe we should just stay local. You know, Huddersfield's pretty good.
Yeah, let's do that.
All right. I'll say we go down to Marsden, sit by the river. Loads of great places there. So just go sit in the sun and enjoy the day.
Have a nice day.
Yeah, you too.
All right. Should we go to Marsden? It sounds quite realistic, isn't it? Did you capture the sound, the door sound from the right-hand side in the beginning? Yeah. I recorded it and then I listened back to the headphones and I was like, oh, is it real somebody coming in or something? Yeah. Okay, so I have got one more demo. This is a music recording I made. It's a choir recording I made in Oxford, Merton College Chapel. It was recorded for Dolby Atmos album for 7.1.4. So it involves 12 speakers originally, but I processed it for binaural playback. So you don't need 12 speakers, but you just need the headphones. So what I'll do, I'm going to start with, I'll play a bit of stereo version of this recording first. And then I'll play the 3D version, right? And then you can see how big the difference could be. All right, so here we go, the stereo version. Okay, now I'll play the 3D version for the same music. Okay, so there's a pretty big difference, right? You can hear this reverb surrounding you from all directions, and the singers seem like they are like a few meters away from you instead of being inside your head, right? So just one more comparison. I'll just switch between stereo and 3D, then you can actually hear the difference more clearly now. So I'll just go back and forth between stereo and 3D. Yeah, so this is just an example of how realistic binaural audio can be. You're basically transported into the recording venue, and it will be more realistic if you actually have a VR simulation. So with the head-mount display, looking at the actual venue and listening to the sound performed in the space, it will be even more realistic experience. And also, if you can also rotate your head, so if headphones come with head tracking function, then you can also rotate your head and the sound will stay at the original positions, even if you move your head. So it's like a real life experience. And even better, if you can have a motion tracking device, then you can walk around in a space and explore the soundscape in the space as if you are in a real life. So the technology is advancing quickly, and this is part of our research, how to deliver more realistic and more immersive sound experience in virtual and augmented reality applications. So I hope you enjoyed the demo and the talk. Right, thank you very much.
Where did your interest in sound production come from, and how did it lead to the current career that you've got developing this amazing research?
Yeah, so it all goes back to when I was like 12 or 13. I had a little hi-fi system that my dad bought me. It was just for stereo playback, but the DAC was like huge, in the 80s, So it had a little equalizer, Have you seen this equalizer? You can adjust the balance between treble and bass. And so I just played with it, and it was so fascinating for me. When I managed to change the balance, the sound becomes brighter, duller, fuller, more punch, bass. This kind of experience actually really caught me, from the beginning. And also I loved music. So, and that was the beginning, I guess. And I started developing my interest in sound recording, doing internship in recording studios. And I came over to the UK to study sound engineering. And also by doing lots of different internships in different places, not just recording, but also I did more research-related, signal processing-related works. And that all got me to really be interested in pursuing my own research in spatial audio. And that all started, when I was about 12, I think.
Great. It seems from your answer and also from your fascinating talk that there's a number of elements to understanding sound, from anatomy, physics, sort of musicality. How do you sort of bring all those together, and where should somebody interested in the discipline start to navigate that?
Yeah, I guess it depends on which area of audio or sound that you work in, because sound is a huge area. There's almost no place that doesn't use audio. I mean, headphone technology is it's an area of electroacoustics, and if you drive a car, then there's always this high-level advanced audio technology being used while you're driving the car. More advanced cars have got this active noise cancellation system, so you don't hear the road noise much, while you're driving. So without us noticing, all this thing going on, there's a lot of audio technology being used in many areas in our life. So it depends on where you work in. So if you work in, for example, noise and vibration, physics and math would be more important part of the things that you need to study. But if you work in music production, then of course you need to understand how human perception works, basic knowledge about perception, but also it's more practical thing that you need to learn, how to manipulate sound by controlling certain parameters. And so there will be more practical side. But then if you want to study more of how human hearing mechanism works, so like audiology, this is also a big area. As you grow older, you lose hearing ability. That's a natural thing. But then you can also enhance the hearing ability by using some devices to insert your ear canal. Yeah, that also requires a lot of research in how human perception works and how the brain interprets the work. So that goes into neuroscience, neuroacoustics level. So yeah, it really depends on which area of audio you want to work in. Yeah, but the basic, the first thing is that you need to love sound. You need to love music. I think that is a good starting point.
I genuinely didn't realise that there were so many aspects to sound. I think I always just take it for granted that the sounds around us. A lot of this technology is really obviously pushing the boundaries of what we hear in different situations. Just personally, I wondered, is the goal of the research to produce a realistic experience or to enhance our sort of experience of sound?
I guess it's both, but ultimately, it's the experience that we want to deliver. At least in my research area, we do a lot of fundamental research in sound perception. So this is an area called psychoacoustics. It's about what affects how we perceive things like localization or pitch perception, loudness perception. And so after we study all these, we want to apply the fundamental theories into practice to deliver a good experience. So what matters in the end from user point of view, especially in music production world or anything that we do, like a games audio is also another big area. But the experience is the first important thing, the sound quality, how to ensure that experience, the quality of experience is high enough. To achieve that, one of the dimensions, one of the pillars of immersive experience is a sense of being there, the realism. So, yeah, when you watch like a film, for example, I don't know, Top Gun, let's say, yeah. I don't know if you watch that film, but if you watch it in an IMAX film, cinema, right? The realism is just amazing, and it makes you be immersed into the content more. Well, if you watch it on a small iPad screen, it will probably be still immersive because the content is so interesting, right? So it's a great film and you like it wherever you watch it, but the experience will be much better. It will be much more immersive if you watch it over a large screen. So the realism and this immersive experience, they are related together. I mean, the realism, or what we call physical presence, sense of being there, that's the lower level element that we want to achieve by doing research, but then it eventually contributes to the ultimate experience. So that's what we are trying to do in our research. Yeah.
Great, thank you. Have we got any questions either from the live audience or from in the room? Yes, thank you.
So, yeah.
So the question was, is it something that can be applied to VR?
Yes, it is already being applied. Especially in games, actually. Yeah, games. A lot of games are produced in VR, and they often come with the spatial audio, virtual acoustics, Because like I said in the beginning, sound is half the experience. So when you play VR game, the visuals 3D, it's very realistic, but then sound is mono. Imagine how strange it would be. That actually breaks the illusion of being there, because the sound doesn't match what you see. Then it's a big issue. So there's a lot of research going on and development. Already some practical products that can do audio for VR, and that's also our research. We're also looking into augmented reality as well. So you hear holographic images and sounds in a real environment, wearing like glasses, and you can project audio and visual objects virtually, and that's a big thing at the moment.
And am I right there's some research that's gone on at the university around using that sort of immersive experience for well-being and health reasons?
Yes, that's also another strand we are exploring at the moment. Sound can also have a very important implication on mental health and well-being. A lot of people experienced during the COVID period, how annoying noise can be, right? Because everybody's stuck inside, and even in a kitchen, you never realize how reverberant, how annoying the sound you hear from like dropping something on the kitchen floor. It's a very annoying sound, and it can actually affect your mental health if you are exposed to a loud noise constantly, right? But then there is also good type of noise, good kind of sound, like a fountain or water features in a city. If you go to somewhere like Huddersfield train station, in front of the station there is this, is that St. George's Square? During the summertime you have this vertical water fountain. It's great. When you hear this kind of sound, then it's another addition of sound to the existing noise, but it kind of balances out. Even if you hear some strange, annoying construction noise from behind you, if you hear some nice water features, sound of nature, or sound of like birds in front of you, it kind of balances out. So this is another research area called urban soundscape. It's actually related to urban planning, how you build a new city, how to improve citizens' well-being, and it's a huge area. Yeah.
Great, thank you. Any more questions from the room?
Yes. Yeah. Yes. Yeah, it is already happening.
So that's a really good question.
Yeah, really good question. Actually, I showed in one of my slides. I go back to the. So
this is about whether you have to record with the technology or whether you can digitally remaster
exactly.
old sound.
You can record everything natively, like using this kind of microphones, and then you can also use equipment to pan different sounds, objects or multi-tracks from Pink Floyd that can be remixed or remastered. That's what exactly happening right now, because Dolby Atmos, this new format, is rising, and sound engineers and record producers are now on big demand on remixing the old catalog for Dolby Atmos, so they suddenly have more jobs to do, because but then you can also use this kind of signal processing techniques. This is just an example. If you have some data that you already captured in nice studios for all the speakers and everything, then you can process the sounds that you already have, dry sounds, convolve them with the data impulse responses we talked about, and then you can create anything really. You can manipulate the sound, make it more like you're listening to in a concert hall, in a studio, in a home bedroom or whatever. So anything's possible.
Well, what's an accessible route into this for people who maybe don't have access to the kind of equipment that we've got here at the university?
Yeah, great question. So again, so if we this is more accessible than before. There is also technology called Ambisonics, which was developed in the 60s and 70s, actually, but then has not been used by practitioners because you needed to have expensive gears, computers that can process it, and everything was very expensive. But since about 10-something years ago, things became cheaper, more accessible. There are a lot of open access tools, software tools you can download and use it on a digital audio workstation. There are a lot of inexpensive software systems you can use, and there are plugins. If you're familiar with music production workflow, it's all based on digital audio workstation and plugins. Before, you needed to have a lot of expensive analog equipment, thousands of pounds. But now you don't need them all. You just need software plugins. So there are a lot of tools available if you want to start exploring spatial audio. There are a lot of tutorials on YouTube these days. So yeah, I think we are in a golden time for doing all this. Yeah.
Great, thank you. I think we've got a question from the live stream as well. That's a good question as well. So for those people who would say that music technology is just a hobby, how would you advise them? What would you say to them about the career prospects for the future?
Okay. As I said earlier, sound is such a huge world. There are so many jobs in the world of audio and sound. It's not just about music production. It's music production. Actually, music is actually a small market compared to if you look into film or games, and there are a lot of software and hardware companies that develop all these different things. And well, let me tell you about my story. Actually, when I came to the UK, all I wanted to be was a recording engineer. That was my passion. I mean, still my passion. I'm still a recording engineer. I do my freelance recording, but I do research and development. I worked in the industry. I worked at LG Electronics in Korea. My job was to develop audio codec at the time. So like the coding technology for mobile phones, like MP3, AAC, these technologies are all based on audio signal processing theories. But then if you don't know some basic principles of how human perception works, there's no way to make practically relevant tools. So all this come together. For example, our music tech course, music technology and audio systems course, they study both practical and technical things like recording, mixing, mastering, which is very important, live sound as well, to understand how the practitioners work in real world. But they also study audio electronics, psychoacoustics, acoustics, room acoustics, programming, how to build a plugin even, So the combination of all these skill sets can open up a lot of opportunities for jobs. So for example, our students work in Fraunhofer Institute. This is a home of MP3 in Germany. That's where MP3 was developed. High-level technologies. So there are a lot of jobs. Apple, Google, all these big companies always recruit audio engineers, sound engineers. So, of course, there are a lot of jobs in a creative world as well. Film, sound is a big area. Games, audio, sound designers, recording engineers. So, yeah, I can spend all day to talk about this. But yeah, anyway, there are so many opportunities.
Yeah, something that surprised me as well looking into this area was it's obviously global, isn't it? You've already mentioned Fraunhofer, Korea, the States, obviously. So it really is a global industry.
Yeah.
But that it's not always concentrated into big cities. I was surprised at how many places there are around the Huddersfield area that take our students and our graduates as well.
Well,
so.
yeah, we have internship opportunities at Dolby, in London. Some students went to Denmark. Bang & Olufsen is a hi-fi company. And also we had some students in the US, studios in the US, Fraunhofer, and another place in Germany. Yeah,
so it really is a global language.
It's a global thing, yeah. And Huddersfield is one of the leaders in this field. And interestingly, in the north of England, there are several universities that are really focusing on the audio side. But Huddersfield is known for 3D audio, spatial audio, and music tech. And yeah, we have good relationships with industry leaders, companies. So yeah, many opportunities.
Any other questions? So that's a good question to finish on.
Yeah.
The last question is, how important is sound to our mental well-being?
So, well-being is affected by all these sensory things, not just sound, but visuals, what we experience, even food and everything, actually affects how you think, how you behave. And the sound is also a really important thing in our daily life. If you're exposed to loud noise and annoying, aggressive, offensive sounds all the time, you don't realize how mentally drained you be. You don't realize it when you are in the environment. Probably after the day, you feel like, oh, why am I so tired? Because your ears have been tortured by the sound, right? And there is also medical evidences, how sound affects mental well-being. Actually, we have an intern from Mexico, Noberto. His research is about to understand how the brain reacts to certain types of sound. So we are investigating into the relationship between brain reaction and 3D soundscape. So when we listen to 3D audio, what happens to the brain? But there is already some evidence that good 3D sound can help people reduce their stress level in hospital settings and other places. So yeah, it's a really important area of research at the moment.